Hey guys, I just thought it would be kind of fun to see how fast it would take me to program Connect 4. It's going to be, I had the idea of programming it as a two-player game with the normal 6x7 grid, and you select a column and it'll drop a chip in. And then it was kind of more of a complicated project than I expected, but it ended up being pretty fun. So I made a quick recording. It ended up taking me about 50 minutes. And so I'm just going to do a little walkthrough of all of the code that I was writing. I sped up the 50-minute video of me coding to 4 times the speed. So we can watch it at 4 times the speed so that you won't get as bored. So this video will probably end up taking about 15 minutes or so. But I just thought this would be kind of fun. And I don't know, I kind of like streaming. I like making videos. I like talking about code, and I absolutely love coding. So hopefully some of this might be entertaining and even informative. I'm designing this video to be something that anybody can watch, even if they don't have like any programming background at all. So we'll get started. So the key behind this project or coding this game, the tricky part is definitely, so you can actually see this timer up here in the corner if you want to kind of watch the progress as we go. The tricky part is kind of structuring the game and storing the game. So in computer programming, as you can kind of see right here, I've got this grid and I program the grid with this line of code right here. It's kind of hard to see with that pop up all the time. But what I'm essentially doing is in the computer's storing this grid like this, and each row has an index value that starts at 0 and ends at 4. Well, in this example, I guess since it's I could redraw this. The grid right here, it's a 7x7 because that's what Connect 4 is. It's a 7x7 grid. 7x6. Sorry, I misspoke. So it's a 7x6 grid. So this is Connect 4. So obviously, like you can put in your piece and it'll go like that. And like I said, the indices are 0, 1, 2, 3, 4, 5, like this. 0, 1, 2, 3, 4, 5, 6, 7. Uh-oh. I drew one too many columns. That's all good. We'll just erase that one right there. 0, 1, 2, 3, 4, 5, 6. Okay, there you go. So as you can see, when a computer stores a grid like this, you basically can reference the rows by its number and columns by its number. So let's say this whole thing was called grid. What we would do is if I wanted to select this square right here, you can notice that is at column 3, row 4. So what I can do is I can literally just write out right here, I can literally write out grid at 3, 4, and then I can do things there. So I can store variables in there, like I can store an X in there, or I could store an O in there. And so this grid value right here, instead of being empty, it can store a variable in there, a value in there. So this is kind of the basic format of the game that I'm doing. The tricky thing with this is there's kind of this interface that gets kind of tricky. So if you've been watching what I've been coding a little bit, you can notice that I've already printed out this little welcome message that it says, hey, welcome to the game. Thank you for playing. This is kind of how it works. And then I also already formatted it so that it prints out the grid in this beautiful format. I labeled each of the columns by their number. And so essentially what I'm going to have the user do is they can select a number, they can type in a 0 through a 6, and it'll drop a token inside that column. The tricky thing was, so this is basically just right here. This is going a little bit faster than I can kind of like demonstrate, but you can see here, I'm just trying to figure out how to get it so that we can get input from the computer. The interesting thing about Python is it makes it, Python's the programming language I'm using right now. As you can see here, this line at this location right here, I'll show that to you. This line right here is basically getting the input from the user, and then it's converting it to a number. Because if the user types in something, I want to convert it to a number so that I can actually do mathematical operations on that. So I'm just going to keep playing. I paused this for a little bit so that I could demonstrate that. The hard part about this right here is I have a couple of these other sections of code that have to do with certain portions of the game. For example, I have these things right here. Let me turn the annotation back on again so that you can kind of see it. So these things right here, this right here, the things with the def and then the yellow words, these are called functions. They're essentially just blocks of code that you can run that whole block of code just by calling that function. So if you look right here, I created a function called game over. And so that's a whole block of code compressed into that one line right there. And so it makes code a whole lot easier and readable if you chunk everything up into these functions, essentially. And so this is kind of what I'm doing. The main part of this game is this play game function, which I've coded right here. And so this is kind of the heart of the game. But then I have all of these things called helper functions, which is just kind of like helper code that I can call multiple times. For example, let's say this column right here is filled up by a whole bunch of values, and it's the max. At some point, if I ask for them some input and they select, I want to put it in column 4, I have a block of code right here called available slot that essentially checks to see if that slot right there is completely full. If it's completely full, I print out a message saying, hey, you can't actually put a piece there because the whole column is full. So that kind of just demonstrates the power of creating these functions, because think of how many times I have to check to see if a column is full. Every single time a user types in a column number, I have to check to make sure that that column isn't full. So it would be really unfortunate if I had to just write that code over and over and over again. But if I have this little function that I can just call each time, it just makes my code a little bit easier. So you can see how it just takes one line to check all of that stuff. Another thing that I have to end up checking is if, for example, the column numbers go 0, 1, 2, 3, 4, 5, 6 like this. What if the user types in a -4? I have to print out a message saying, hey, sorry, you can't type in a -4. Or if they type in like a 42, I have to say, hey, you can't type in a 42. It has to be between a 0 through 6 because those are the only available inputs. Also, if the user types in like words like hello, or even if they just type in a couple of spaces, I need to check for this to make sure that my game doesn't crash if they type in something that's not allowed, because numbers are the only things allowed. Cool. So let's take a little bit look at what I'm doing here. At the moment, I'm focusing on this function called the bottom spot right here. And the purpose of bottom spot is, for example, as you can remember, as I showed earlier, the indices look like this. So if a user typed in a 3, for example, and I just put it in the first available slot, the first available slot would be here because it starts at 0. So what I needed to do is I needed to find the bottommost available spot. So it would start at the bottom and check to see. So if they selected column 3, and let's say this is kind of the current state of the board. There's an X, O here, X here, O, X, X, X. So as you can see, X is about to win on column 4. But so what I have to do is if they select column 3 right here, I need to check to see what the bottom location is. And you can just looking at that, notice that it's that location right there. So my bottom, the bottom function, bottom spot, basically just finds, it selects the column and it starts here and says, hey, is this filled? It is. So I'm going to move on to the next one. Hey, is this filled? It isn't. So I'm going to return, I'm basically going to notify the other portion of the program that the indices 2 and 3 is the most bottom available spot right there. Cool. So that's just some kind of overview of kind of how I got the input and got that to work. So now what I need to do is I got the input to work, as you can see here. And so a user can type anything. And I created this kind of like switch called xturn. And I set it at the beginning equal to true. So basically there's only 2 options, true or false for xturn. And so if it's true, that means it puts in an X. If it's false, it puts in an O. And so I basically switch xturn. I alternate between switching it on and off between true and false, back and forth between each player so that it can put in an X and an O if needed. So as you can see here, I am working on checking the rows to see if somebody has won by the rows. Now, computers are super fast, which makes this really absolutely super fascinating, actually. So all of this code that I did right here, if I have the grid, what this is doing right now, the code that I wrote, is it checks every single spot in this order, kind of like this, and it just keeps checking, keeps checking, keeps checking until it finds a spot where 4 are in a row. So for example, if we have a board like this, X, 0, 0, 0, x, and then we have x, 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 and then we have 0, and then x, 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 x. What this code's basically doing is it's going to go row by row by row, and it's going to take a tally of consecutive characters. So obviously it's going to start at x, so we're going to have tallies for x's and o's, and we have one x, sweet. So we have one x here, so we're going to move on to the next one, which is an o. Since this is an o, we're going to remove the tally for the x and add a tally for the o. And then we're going to go here, which adds another tally. Then we're going to go here, which adds another tally. But once we get here, there's another x, and we wipe out the o's. So once we get to the end of the row, since there wasn't 4, that doesn't count as anything. So then if we go to the second row right here, we can kind of do the same tally thing right now, where basically what it's going to do is, so we can kind of just count up the tallies. We're going to just go here, then here, then here, then here, then here. And you can kind of see this process. Let me switch back to the color. So we start out with an X, then we start out with another X. And then once we hit this O right here, we go and we put a tally on the O, and we have to get rid of all the previous X's. And then once we get to this cell right here, we notice that, oh, that's an X. So we get rid of the O tally and we put an X, and then we get to the last one right there. So you kind of know the process. So once we get on to this third column, we have an empty space, so we don't add any tally. And then we have an X, an X, an X, an X. Since there's 4 X's, at this point we say, hey, the game is over, X has won. And that's what this little statement right here, this count equals 4 return true thing says. If the count of either X's or O's hits 4, we return true, basically saying the game is over. So that's how we do the rows. And the columns are in the same exact format, but instead of going row by row by row, like this, row by row by row, what we do is we instead go column by column by column, doing the same exact tally fashion. Is this an X? Is this an X? Is this an X? Is this an X? 4 of them in a row, so we're good to go. I hope that makes sense. So now the diagonals are really, really confusing. And I hadn't really thought of how to program Connect 4 before I jumped into this project. And I was coding away, printing out this grid, getting the user input, and checking the rows and columns was actually fairly easy because it's just taking up a couple of totals. But I was like, how in the world am I going to do the diagonals? So what I thought is I was going to do the same tally method as before, but I have to check on the diagonals. So basically, I'm going to check this diagonal, then I'm going to check this diagonal, but I'm not going to check this diagonal because you notice there's only 3 spaces. So this got really, really tricky because I had to determine what portions of the grid I actually end up want to check. So you can tell that I'm not going to check any of these squares at all because these diagonals don't allow 4 spaces. Essentially, the only 4 space diagonals are here. And that's only when it's cascading down to the right. If it's cascading down to the left, I have to get rid of some different things. So that's why if you notice in my code, I broke it down into a section that essentially said cascade to the left. So right here, you can see I have the check rows portion. Let me switch. I have the check rows portion right here. And then I have the check columns portion, and now I'm checking the diagonals cascading to the right. And the process is very, 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 very similar to the rows and the columns, but instead of totaling up an entire column, it just totals down a diagonal. And you can see that I've pretty much got it figured out. Now I'm just kind of testing a couple things. So I finished the cascading to the right. So now I just copied and pasted this and put it to the left. So if you look at this, to go to the right, to go from this cell to this cell right here, you basically turn the index. So this index right here is 0, 0. To get to the bottom right one, you just add 1 to both of them like this, which is why I had the plus equals 1. But then when I wanted to go to the left, wow, I can't believe this ended so fast. I got so excited about explaining this that I just completely blew away. So if you notice, to go from the left, so if this is our grid, to go from this cell to that cell, we're going from index, let me just draw these out real quick. We're going from index 0, 0 to index 1, 1. And then let's say we're trying to get from here to here. We're going from 0, 2 to 1, 3. You can see that, see how it's 1, 3 like that. So the pattern here is we just add one here and then add one here. Now to go to the left, so that was going bottom down right. To go down left, it's a little bit different of a pattern, as you can see here. So I'll just kind of erase this real quick. So if I wanted to go from this cell to this cell, we're starting at index 1, 2. That's where the circle is, 1, 2. And we're trying to get to 2, 1, 2, 1 like this. So you'll notice that we're basically 1, 2, 2, 1. Yeah, so what you can see here is what we're essentially doing is we're checking to see this one goes up 1 and then this one goes down 1. So that's kind of why I do that arithmetic right there. So this was really fun. I can't believe that I actually ended up programming this entire Connect 4 thing in 50 minutes. As you can see, it involves a lot of typing. Coding is a ton of fun, and it's a lot of on-the-spot things. Some really consistent normal things that you see in a lot of code are these things right here. These are called loops. These are called variables. And then I already talked about the functions where it has the def name keyword. And so that's kind of just like how you end up making a whole bunch of code. Anyways, I hope this video was kind of fun. I just thought it would be kind of interesting to show how to code something really, really fast and kind of just show you all the code and kind of break you through the thought process that it takes behind programming a simple game like Connect 4. Tic-tac-toe is definitely a whole lot easier because it's just like a little 3x3 grid instead of a 6x7 grid. And it's a little bit easier to check the diagonals and stuff. But this was a really fun project. So yeah, that's all I have for you today. I hope you have a good one. Thanks for watching. Bye.